Hello, I'm Norbert Gleicher, MD. I'm the Medical Director and Chief Scientist here at the Center for Human Reproduction, and I'm here with two other people with white beards, the two Davids, David Barad and David Albertini. And it's a pleasure having you here, gentlemen, today for the discussion of a topic that we were specifically asked by some of you in the public to address, and that is the so-called three-parent embryo. David Albertini, do you want to get started?
Yeah, happy to jump into this topic. Again, it is something that I think attracts a lot of attention from the press, but I think it's a bit misleading, both from the history of the technology and why this is actually being considered today. So let's do just a quick step backwards, which was as we began to realize that the eggs of older women seemed to be more prone to chromosomal errors and and other kinds of errors. We often talk about how maternal aging is sort of paralleled by the loss of developmental competence in the oocytes, coming from that older ovary, as it were. So really it was some time ago, and it was Jacques Cohen and Carol Brenner, actually, I think was the lead author.
And Jamie Griffith at NYU.
That began to consider what would happen if we transferred the nucleus of an older egg into the cytoplasm of a younger egg.
Where the mitochondria are.
Yeah. Right. And as is, I think, held true, the original idea was that one of the failing qualities in the egg as it aged, was that it was unable to meet the metabolic demands of fertilization and early development. So the finger was pointed quite early on at the mitochondria being deficient.
Sort of like getting new batteries.
New batteries, needing more juice, more ATP to drive development, and I think from a conceptual point of view,
makes sense.
They were it made a lot of sense. And they really were the first to kind of forge the idea and the methodology to say, could we actually do this? Could we take a nucleus out of one egg?
Before they did that, they actually said something else. They said, can we take a little bit of plasma from a young egg donor
That's true.
and put it into an older egg, and after removing some of that older plasma, just basically doing an infusion of young mitochondria.
To rejuvenate. I think the idea was, maybe those mitochondria from the younger egg would rejuvenate that egg.
And they did about a dozen cases before the FDA shut them down.
Right. And I believe there were a couple of children born from this over the years, but as you say, it just became a little too sensitive a subject, not just from an ethical point of view, but I think this was genetic engineering, from the very beginning.
But let's explain maybe to the public here that this is where the term three-parent baby comes from, because mitochondria have their own separate genome.
That's correct.
From the rest of the genome, and that those genes are only transmitted from the mother to the child. In other words, our general belief that when an embryo is created from egg and sperm, it's a 50-50 job is really not true, because there is a little bit of an additional contribution from the mother through the genes of the mitochondrial pool and whatever percentage that represents. So an embryo gets a little bit more genetic material from the mother, and if you feed mitochondria into this process from a third party, then suddenly there are not only two genetic parents, but three, and that's where the term three-parent IVF is coming from.
Right.
So every time we are mixing in the mitochondria of a donor, there's a third genetic parent involved.
Right, right. So we've got dad's genome, we've got mom's genome, and then we've got mom's mitochondrial genome. That's kind of the three parenthood nature of this. And then if you fast forward, I think reproductive technology in general began to evolve. In fact, in the late 90s, early 2000s, the era of animal cloning came about, where some of the really fine technology was enabled that allowed us to now be thinking about not just an infusion of young cytoplasm, but could we actually take the genome out of one egg and replace it with that of another one? And that's, you know, really where we're at right now. But in terms of why patients are asking about this, they need to be reminded that this is, first of all, a very experimental technique. And second of all, its current development is not to overcome the problem of aging. It's to overcome the problem of mitochondrial disease inheritance. So there are women who carry mutations in their mitochondrial genome, as you were talking about it before. And we now know...
And those diseases, therefore, are only transmitted from mother to offspring.
That's correct.
Never from father.
That's correct. And so what's evolved over the years is at least the prospect that, because now with the genomic testing that can be done, we can tell who are carriers of those mitochondrial gene mutations. And the idea would be that rather than passing on the bad mitochondrial genes, what if we took the nuclear gene from a woman carrying those mutations and put it into an oocyte that had healthy mitochondrial genes? So that would mean that there is a mitochondrial gene parent. We happen to call these the cytoplast, okay? There would be a maternal parent. We would put her genome back in that egg. And then that egg, if it survived the procedure, which it sometimes does, would be fertilized with the partner's sperm. So you reconstruct this thing. Yes, it does have three parents. And yes, in theory, it could bypass the inheritance of this mitochondrial disease predisposition. But bear in mind that any offspring generated from this would be carrying a different mitochondrial genome, okay? Where this stands at this point is that a company in Spain has set up an experimental trial in Greece. Their government has essentially permitted this procedure to move forward for testing. But at the same time, in the United Kingdom, the HFEA, which is a regulatory body that oversees this kind of work, has now given permission to a group, I'll remember in a minute, the group that is now testing the feasibility of
Yeah, but they have done only one
But
case.
that's for
so
mitochondrial.
That's for
disease.
mitochondrial diseases, whereas frankly, what's going on in Greece is a company is pushing the use of this to overcome the aging problem that we started talking about.
And there are other clinics around the world in other countries, not in the United States.
In the United States, this is forbidden.
We can't
At the
do it.
present time, the FDA does not
But
allow
there are
it.
other countries that are pushing this idea, other clinics, and actually marketing it as a marketing tool to attract patients.
Yeah, of course.
Yep.
Yeah. Like some
unproven.
other things. Yeah.
Yeah.
Now,
I mean,
it's not only unproven, I would go even further. And I'm not talking now about mitochondrial diseases, which
Could be helpful.
which an obvious problem, but fortunately an exceedingly rare
Yes,
problem. Those
yes.
are very, very rare diseases. But the hypothesis that aging of oocytes or aging of ovaries is in any way mitochondrial driven has become very, very questionable. I mean,
Right.
when I first heard about it, when Griffin and Jack Cohen and so forth made that point 20 years ago, it seemed quite logical, but what we know about the biology of mitochondria today, I would say that this concept is not really viable any longer. Would you agree?
I'd agree, and when you look at this whole sort of the biology of aging, you really can't rely on something as simple as mitochondrial metabolism. Okay, I mean, now we're in the world of epigenetics and all these other things, so aging is clearly a far more complicated thing than just a mitochondrial deficiency.
There might be other things in the cytoplast that could be helpful for the cytoplast. But,
Maybe.
But we don't know yet.
Maybe, but
Right.
The point is that it's not proven, that what's out there are a couple of case series, they're not controlled, they're really no
Actually, there was a Ukrainian center that did it before the war started very aggressively, never reported on it. And the rumor mill was that the data simply didn't pan out and therefore nothing was written. The Greek data, same thing in a way.
Right.
Has really, and again, I want to re-emphasize, we are not talking about mitochondrial diseases. We are talking about mitochondrial exchanges for aging purposes.
Right.
Again, the Greek data so far has not shown that it does anything. And then there are probably other places in China, maybe in Korea, from what I have heard, where similar experiments are going. But since nobody publishes, that is always a very bad sign in medicine, because if nobody publishes, it means that things don't work. And therefore, I think I am speaking for everybody here at the Center for Human Reproduction when I say, or when we say, be very, very cautious when you read or hear about mitochondrial exchanges to treat advanced female age. There is really no support for such an approach at the present time, unless you can enroll into a true clinical trial, but we are not aware that anywhere such a trial is currently going on. Anything else to say about this subject? Okay, then we thank you very much for listening.